Hello. Have you ever wondered about Mars and asked yourself, will humanity ever move to and live on Mars?
Let's explore and discover Mars to answer this question.
Mars, the fourth planet from the Sun, is one of the most studied planets in the solar system. Its harsh surface conditions, the presence of water, and the potential for past life have made Mars a captivating subject for scientific investigation. Over the past decades, scientists have relentlessly searched for clues to unravel the secrets of the red planet. Mars' surface and unique geology. Mars, also known as the red planet, has a unique surface with special geological features that scientists continuously explore. The surface is largely covered by iron oxide, giving it a characteristic red color. However, beneath this red exterior lies fascinating structural and geological attributes, including massive volcanoes, deep valley systems, and complex features unlike any other planet in the solar system. Olympus Mons and the volcanic system. Olympus Mons is the largest volcano in the solar system, standing about 3 times taller than Mount Everest on Earth, with a diameter of up to 600 kilometers. It is a shield volcano formed from numerous lava flows over time. The relatively flat surface of Olympus Mons indicates that lava steadily overflowed and spread evenly. This volcano reveals that Mars once experienced intense volcanic activity, potentially creating environments conducive to life. Valles Marineris Canyon System. Valles Marineris is a massive canyon system stretching about 4,000 kilometers, approximately 10 times the length of the Grand Canyon on Earth, with depths reaching up to 7 kilometers. Studies suggest that Valles Marineris was formed due to the expansion of Mars' crust, along with tectonic and faulting activities.
This canyon system is crucial for understanding Mars' geological shifts over time. Mars rocks and terrain. Mars has 2 primary terrains, highlands in the southern hemisphere and low-lying plains in the northern hemisphere. The major difference between these regions is attributed to tectonic activities, meteorite impacts, and geological phenomena. Rocks and minerals on Mars' surface, such as silicates, iron oxides, and various other minerals, provide evidence of the planet's complex history. Sand and dust storm. The Martian surface is covered with fine sand and dust due to erosion from winds and meteorite impacts. Mars has the largest dust storms in the solar system, which can engulf the entire planet for extended periods. Dust storms not only reshape the landscape, but also pose significant challenges to human exploration missions. Impact craters. Mars has many impact craters caused by meteoroid collisions. These craters allow scientists to study the planet's age and examine the layers beneath the surface. Gale Crater, where the Curiosity rover is currently exploring, is a prime example as it contains signs of ancient water. Water on Mars and the potential for life. For decades, Mars has been the focus of scientific studies and discoveries related to the possibility of water, a fundamental element for life. Finding water on Mars not only illuminates the planet's climatic history, but also opens up the potential for life, possibly in the form of ancient microbial organisms. The north and south poles of Mars contain water ice, similar in composition to the ice at Earth's poles. During winter, Mars poles experience extreme cold, leading to the accumulation of both carbon dioxide and water ice. Seasonal changes suggest that water ice may remain stable over long periods, making it a potential resource for future human exploration missions. Evidence of ancient water flows. Evidence of ancient water flows has been discovered through geological features like channels and valleys. Rovers like Curiosity and Perseverance have documented signs of ancient river and lake beds, indicating that Mars once had a warmer and wetter climate. The presence of water in the past suggests that the planet may have hosted environments suitable for microbial life. Discovery of liquid water beneath Mars' surface. One of the latest findings is the existence of liquid water beneath the ice in Mars' southern pole. Data from radar instruments suggest that layers of liquid water might exist under the surface, similar to subglacial lakes on Earth. This discovery creates opportunities for further research into the possibility of extremophiles, organisms that can survive in extreme conditions. Search for organic compounds and life-related molecules. Probes have detected some organic compounds on Mars, including methane, a gas that can be produced by biological processes. Although there is no conclusive evidence that this methane is biological in origin, its presence opens new avenues for investigating the possibility of life. Implications for future missions. The ability to access and use water on Mars is a crucial factor for future human exploration. Water is not only essential for life, but can also be split into hydrogen and oxygen, providing energy and oxygen for astronauts. With the potential for liquid water and ice, Mars may be the most feasible destination for humanity's extraterrestrial settlement. Composition and structure of the atmosphere. Mars has a much thinner atmosphere than Earth, with atmospheric pressure at only about 1% of Earth's. The Martian atmosphere is made up of approximately 95% carbon dioxide, 2.6% nitrogen, 1.9% argon, and trace amounts of oxygen and water vapor. Due to its high concentration of CO, Mars' atmosphere lacks the greenhouse effect necessary to retain heat, resulting in extremely low temperatures on the planet. Temperature and large thermal variations. Temperatures on Mars fluctuate greatly, ranging from about -140 degrees Celsius at night near the poles to around 30 degrees Celsius during the day at the equator. This extreme temperature range is due to the lack of a thick atmosphere to maintain stable temperatures, leaving Mars' surface subject to severe day-night temperature swings. Global dust storms. Mars is known for having the largest dust storms in the solar system, which can last from several days to months and can envelop the entire planet. These dust storms not only affect visibility and the operation of rovers, but also pose a major challenge for future human missions, as they can reduce the efficiency of solar panels and impact artificial habitats. High levels of ultraviolet and cosmic radiation. Unlike Earth, Mars does not have a strong magnetic field to shield it from ultraviolet radiation and cosmic rays from the Sun and outer space. Due to the thin atmosphere, the amount of radiation reaching the Martian surface is significantly higher than on Earth, posing a hazard for life and a major health risk for humans during prolonged missions. For humans to live and work on Mars, advanced technologies will be required to protect against radiation, maintain atmospheric pressure, and regulate temperature. Future Mars missions will need to study the planet's atmosphere in greater depth to prepare for the establishment of safe habitats. In the coming decades, Mars will remain a focal point of space exploration, with numerous missions planned to address the unresolved questions about the Red Planet. Space agencies worldwide are focused on gathering more data on Mars' atmosphere, surface, and potential conditions for life, while also preparing for future human settlements. Below are some of the major avenues for future Mars exploration. Exploring the possibility of life. One of the primary goals of future missions is to search for signs of life, whether as ancient microorganisms or their traces. The ExoMars missions, a collaboration between the European Space Agency and Russia's Roscosmos, will deploy a rover capable of drilling up to 2 meters below the Martian surface to collect samples. This significant advancement aims to access areas potentially shielding microorganisms from the harsh surface conditions. Sample collection and return to Earth. NASA and ESA are collaborating on an ambitious plan to collect Martian soil and rock samples and return them to Earth. The Mars Sample Return Mission, involving specially designed rovers and spacecraft, will enable scientists to study these samples in greater depth and detail, helping to identify biosignatures and providing insights into Mars geology and climate history. Exploring Mars polar ice caps and subsurface water. Mars polar ice caps are believed to contain significant water reserves, and studying these regions could offer insights into the planet's climatic past. Future missions will likely include probes capable of accessing and analyzing the ice layers, to confirm the presence of liquid water or organic compounds within the north and south polar ice layers. Preparing for human missions to Mars. Space agencies, particularly NASA, are preparing for human missions to Mars within the next decade. Advanced technologies like landing vehicles, long-duration spacecraft, and self-sustaining life support systems will be essential for safe journeys. NASA's Artemis program, initially focused on the Moon, is also an important stepping stone for more distant missions to Mars. In situ resource utilization. To enable self-sustaining missions on Mars, ISRO technology will be developed to utilize resources on the planet, such as converting CO from the atmosphere to create oxygen and fuel. This will not only reduce mission costs, but will also support long-term human activities on Mars. Climate studies and atmospheric modeling. Mars' climate and atmosphere still hold many mysteries. Understanding phenomena like global dust storms and how Mars' thin atmosphere interacts with solar radiation will help scientists better predict environmental changes and prepare for future human missions to the planet. We've just explored some of the fascinating secrets of Mars, the mysterious red planet of our solar system. Every new discovery opens up exciting possibilities for the future, from the potential for life to human missions to Mars. With advances in science and technology, the day we set foot on Mars and learn more about this planet may not be far away. Stay tuned and join us as we continue to explore the wonders of the universe.